Linked list. This is another form of data structure other than array. Array has all the memory location in a sequence, while linked list, the memory location is not required to be at a sequence. If you have a less memory and your memory in your system is segmented, then also linked list is capable of keeping large number of data, because each data node keeps the address of another data node, and there is no condition that these data nodes will be in a sequence. Let's see how it happens internally. We have a linked list. There we said we have one node. This is the node of the linked list, which has a data part and address part. This is the address part. Data part will keep the data, and address part will keep the address of next node. Now, this is an example of linked list where I have two nodes. Node 1 has data 1 and node 1 has address of node 2. When I say it's a complete linked list, I said there is a header node and there is a tail node. Header node contains the address of the first node and tail node contains the address of last node. Why this header and tail is required? How I will reach to this first node? To reach this first node, I need the address of this first node. To get the address of this first node, I have to store that address somewhere, and that is the head. So to access this linked list, I go to header node, read address of first node, and then access linked list. I will go to node 1, read its data. Then I will read the address of second node, then read the data of second node, and if it has the address of another node, in similar fashion I can read all the chain elements. In some of the conditions you need the last node directly, then this tail node will be helpful. You can see this single node has data and address of next node. This is only a single element. If it is a single element, that is this node is keeping address of only one node, then it is called singly linked list. If here we have two address nodes, one address node, second address node, then it is called doubly linked list. In the case of doubly linked list, you have data node and here you again have a address node which will keep the address of node 1. So in that case, you can read data from node 1 to node 2 and then you can read data from node 2 to node 1 also. But in singly linked list, you can move only in the one direction. From node 2, you cannot go to node 1 because you don't know the address of node. But in doubly linked list, you can move in both the directions. Example of linked list. Let's create a link. I create a node. I have empty head node and tail node. So when you will create this first node, you have to keep its address to access this node. This address would be kept in head node. Since this is only a last node also, so this address would be kept at the tail node also. Now after first node creation and joining happen, it will look like this, as a head is pointing to this first node and even tail is pointing to this first node. Let me introduce a second node here. When you will introduce a second node, your first node will point to this second node. Your second node is pointing to null, that is there is no node after it. Your head node is pointing to the first node and tail node is pointing to the last node. Let me introduce third node. Your head will connect to first node connect to second node connect to third node, and tail is connecting to the last node. So this is how the linked list will look like. Insert a node in existing linked list. This even we have seen in the array. In array, if you have to introduce a number between the array, you have to move those elements to the right hand side so that you can create a space between that array or at that array location. But in linked list, you don't have to do any shifting. You just have to introduce a node and have to do some rejoining of links. What is that rejoining of links? Initially, this node 1 is pointing to node 2, but now this node 1 is pointing to node 3 and this node 3 is pointing to node 2. Let me explain it again. This node 1 has address of 00HXZ, which is the address of this node. Initially, 00HXY is kept here. H is at node 1. So now this address that is 0 access y, that is address of node 2, is moved to this third node. And now when you will access this node, you will just read head node, the address of node 1. Node 1 will have the address of node 3. Node 3 has the address of node 2, and it's done. Head is still pointing to the first node and tail is still pointing to the node 2. So this is called a insert a node in existing linked list. Let's see again one example around it. We have 0, 1, 2 and 3, and we have to insert a new node at this position. That means at second position in a linked list. When I will say second position, it is after first node, that is after node having data 0. So I will create a new node that is having the data 4, and the address of this node is kept at this position. The address of this node, which is initially kept at this, is kept at temporary, and that address is moved to this address node here. So now your header will read the first node will read this node, and this node will read to the next node. What is the algorithm around it? Let me show you. If count double equals to index, then current dot next, then current dot next is equal to temporary. I have saved it temporarily. I have created a new node. That address is kept at current dot next. This is the new node whose address is kept here. New node dot next, that is new node dot next, this position will have the address of this node, which I have kept it temporarily in this variable, and new node is inserted. So if a problem says that I have to insert lots of new nodes or delete lots of new nodes, then linked list is a better option than array. Java linked list. Till now what we have seen is a linked list as a data structure. Now I will tell you what Java is giving you in terms of linked list. When Java implements this linked list, it is not a single linked list, it is a double linked list. This is the first thing you need to remember. That means you can iterate it from first node to last node by a header, or by a tail you can iterate from last node to first node. Linked list implementation of the list interface implements all optional list operations and permits all elements including null. In addition to implementing the list interface, the linked list class provides uniformly named methods to get, remove, and insert an element at the beginning and end of the list. These operations allow linked list to be used as a stack, queue, or double-ended queue. I again repeat, these operations allow linked list to be used as stack, queue, or double-ended queue. Due to the methods available in linked list, you can use this linked list in terms of these data structure. This linked list will start behaving like a stack, queue, or double-ended queue due to the methods available in this linked list. This is the interface java.total.list, and this is the class which is implementing this linked list. So example would be list L1 is equal to new array list. L1 is equal to add 5. Here even you can have linked list. Note this implementation is not synchronized. This point is important. Array list or linked list, which are the classes of the list which is implementing this interface, are not synchronized. If multiple threads work above it, then the data can be changed at any time. These are not synchronized. There is one more part that I need to take care of. In Java, when we talk of list, it is not simply an interface. It comes under a hierarchy of collections. And list is not a standalone there. There are others also. What are these? What is collection? Let me tell you that also. Collection interface. The collection interface are divided into two groups. The most basic interface is java.total.collection, which has the following descendant: set, sorted set, navigable set, queue, concurrent blocking queue, concurrent transfer queue, DQ, blocking DQ. The other collection interface are based on java.total.map and are not true collections. However, these interfaces contain collection view operation, which enables them to manipulate as collections. But map is not a part of collection. That's why even Oracle said that these are not a true collection. Under map you have sorted map, navigable map, concurrent map, and concurrent navigable map. This whole page I have taken from Oracle Docs. How this collection will look like in a tree form? Let me show you. I have an iterable as an interface. Then I have collection, and under collection I have list, queue, and set. This thing you need to remember. I have iterable interface, collection interface, this orange is interface. Then I have list, queue, and set as interface. Under list I have array list, linked list, vector. Under queue I have priority queue or DQ. Array DQ is implementing this DQ interface. Under set I have hash set and linked hash set. Also under set I have another interface called sorted set. For sorted set we have tree set. There is a difference between array list, linked list, and vector. Basically we have talked about linked list. If you talk about array as list, that is, you don't need to identify the size of the list in initial stage, then it is array list. When that array got filled, that array list by itself increases its size by 2 or multiplies its size by 2. Vector is an again implementation of under the list interface, but it is synchronized. Otherwise, when you have to increase the array size at runtime or at execution time, then array list and vector is the answer, but vector is synchronized. Let's see all this in a demo in next video.